Ever wonder why a straw looks bent in a glass? Or why sunlight exploding through a prism becomes a perfect strip of color? It's not a trick of your eyes. Light is doing things that seem impossible. It bends where there's nothing to push it. It splits white into rainbows without paint, and it behaves like a smooth wave and a tiny particle at the same time. Light is an electromagnetic wave. Think of it as oscillating electric and magnetic fields. But when it hands energy to something, it does that in tiny packets called photons. That's not just theory. Experiments force us to accept both descriptions. Waves explain interference and patterns. Photons explain how energy moves in chunks. Hold both ideas in your head, and the rest starts to fall into place. When light hits a mirror, it obeys a simple rule. The angle in equals the angle out. That plain rule is why mirrors give you an accurate reflection, why periscopes work, and why reflections can be so sharp. Smooth surfaces send light off in one predictable direction. Rough surfaces scatter it, so we see diffuse glow instead of a clear image. Drop light from air into water or glass, and it bends. That bending follows a measured rule. The change in speed between materials forces the path to change. That's why a straw looks broken, and why lenses can focus sunlight to a point. The amount it bends depends on the material's refractive index. Basically, how much the medium slows light down. Different colors bend by different amounts. Blue light slows and bends more than red inside the same material, so white light fans out into a spectrum. That's dispersion, and it's why prisms and raindrops make rainbows. The material separates wavelengths, creating color from pure physics, not paint. In a vacuum, light sets the speed limit of the universe: 299,792,458 meters per second. In materials, it's slower, and that slowdown is the root of refraction and dispersion. That constant ties into relativity and defines how fast information can travel. These behaviors aren't just classroom facts. They're the backbone of modern tech. Fiber optics trap light with total internal reflection to stream data across continents. Camera lenses and telescopes bend and reflect light to reveal detail we couldn't see otherwise. Lasers harness coherent photons for surgery, manufacturing, and precise measurements. And quantum optics is now manipulating single photons for secure communication and ultra-sensitive sensors. If you want more clear, no-fluff science that changes how you see the world, subscribe and hit like. Follow the channel and turn on notifications so you don't miss the next deep dive. Simple facts, real demos, zero nonsense.